Again, guys, to another one of our math session, where today we're going to be looking at the topic measurement, and we're learning how to calculate the total surface area of solids. We're going to focus on two solids in this video, the cube and the cuboid. And a solid, as we would know already, is a three-dimensional shape, and we have faces on the solid, and each one of the faces, as we would know already, is a polygon. And we would have learned in previous classes how to calculate the area of polygons. So in calculating the total surface area of a solid, all we're going to do is just combine that knowledge that we have together to get the total surface area. So in my hand right here, I have an example of a cube. And if you look at the faces, you would notice that each one of the faces is in the shape of a square. Alright, I have congruent faces on either side. So this pink one, the same as this green one, the same as this, and this blue one is the same as this. From the diagram, you can also see that all my measurements are the same. So it means that this shape right here is a square. So in calculating the total surface area of this cube, I would first calculate the area of this face, which is a square. And the area of a square is length times length, which is 5 centimeters by 5 centimeters, which is going to give us 25 centimeters square. And since I know that from this example, I have 6 faces, 2 green, 2 pink, 2 blue, so that's a total of 6 faces. So I'm going to multiply the area of one face by 6, which gives me 150 centimeters square. So my total surface area for this cube would be 150 centimeters square. And if I want to sum up all of that in a formula that is easy for me to remember, I can just put total surface area of a cube is 6 times L squared. Since I'm using the same, we know that I can just square that to simplify it. So that's the total surface area of a cube. So we're going to move over now to finding the total surface area of a cuboid. Now the only difference between a cube and a cuboid is that faces, instead of having squares all around, I have rectangles. I have 6 faces just the same, but there are 6 faces of rectangles. Alright, I have 2 that would be congruent just the same. This green one would be congruent to this green one over the other side. This blue face would be congruent to this one on the opposite side. And the same thing for this pink one, which will be congruent to this. So I have 2 of each. Alright, so I'm using the measurement. Here's an example of a drawing of a cuboid. I have one rectangle here that I'm going to calculate the area of first. And I'm using this one, 15 times 5, which would be the height. Next we have the area of another rectangle on my cuboid, which is going to be this one, 3 times 5, which is going to give me 15 centimeters squared. And then the top or bottom, which is going to be 15 times 3 centimeters squared. Alright, which gives us 45 centimeters squared. Now because I know that I have this one at the front, there's another one at the back. So if this is 75, when I'm going to combine everything to get my total surface area, I'm going to add this twice. So it's 75 plus 75. This one right here, I know that I have 2, one at this end and one at this end. So I'm going to add that twice. And the one at the top and the bottom is there twice. So I add those numbers twice. So I get 270 square centimeters for my area. Now to simplify all of that, I could put 2 length times the height, which would be the area for this one, rectangle. 2 base times height, which would be the area of this rectangle right here. And 2 length times breadth, which is going to be the area of the rectangle at the top and the bottom. And if you want to go simpler, you can factorize the 2, take that out, and all these, we place them in one bracket. So I could multiply these 2, add it to this, and then multiply the overall sum by 2, and that would give me my total surface area, 270 square centimeters.